Hey everybody, so this is a new view. I'm in my garage. And why am I in my garage? I'm going to be putting together a longer 10-watt diode laser. It's the Ray5, and I want to share this with you. So let's get started. So, just to clear this out of the way, yes, Longer sent me this. They are not, however, paying me to do the video. Therefore, any review information that I give you is truly based off of my opinion and my experience. Now, there are a ton of people that have done reviews on this, unboxings, assembly, and all of that. So all I'm going to do is whisper gently and softly into your ear as I put it together, because I want to get to the part where I'm actually using it and showing you how I use it in conjunction with my bag making hobby. So you can see here from the photo that this is actually one of those open bed kind of diode lasers. It is a 10-watt laser. Don't be confused by the name Ray5. That did kind of throw me off a bit, but it's a 10-watt laser, and you can actually upgrade this one to be a 20-watt laser. If you want later down the line, you can just replace the laser head and purchase it straight up from Longer. So at first, gonna review the 10-watt laser for you all, but the assembly is basically everything is in this box that I need to get up and running. Okay, now just a quick word of warning. So typically when you order a laser like this, they assume that you already have some of the little attachments and things and widgets that come with a laser, or that you need with a laser in order to vent things and have airflow. So they did provide me with the air pump so that I could have air assist. Air assist is important for keeping your laser head clean. It also helps make cutting faster, which is kind of important. It does help with the soot and the char. That I have found, at least. I always use air assist, so they did provide me with that. However, they assume that you have, like a protective covering. You don't have to have that. I do, because at any point, my kids could just run in here and I'm like, ah, laser. So, and the other thing is the honeycomb bed, which, a lot of people don't realize that they need, but if you're gonna do any cutting and you're not gonna just engrave, you need the honeycomb bed and a protector for your table so you don't laser through your table. That's not an ask me how I know moment, but it probably will be. All right, so before we start building this, because I swear, I'm gonna get to it, what's the difference between a diode laser and a CO2 laser? Well, there's several different kinds of lasers. There's also fiber lasers. So I have a CO2 laser here, and as you can see, this thing's pretty bulky. It can do, about 12 inches tall, 20 inches wide for the area, and it's in a box, which makes it super restrictive if I want to do something slightly larger or oddly shaped even. The laser head can't really be moved around as much and as freely as you would think when it's contained in a box like this. Actually, we had to 3D print stilts to lift it so I could do tumblers. With the diode laser, since it has this open frame kind of setup, you have a little more wiggle room, but you're more limited on the cutting power, the engraving power, and the kinds of materials that you can do. They're great for engraving. They're good for cutting thinner materials. So theoretically you could, blow the laser and go like 100% power and cut through 1/2 inch of plywood. But I don't really do anything that requires that kind of power. This is great if you want to make bag tags, which is the thing that I'm gonna be making and primarily using this for. So it's just one of those things to kind of bear in mind. This takes up a lot less space. That's huge. It's great, but it's huge. It's 250 pounds, and I thought that this was going to cause my husband to want a divorce. Okay, so I got it all put together. About the only thing that I would say is the screws that we were provided for attaching the laser head from the back side. They have these little nylon rings. The screws were maybe a millimeter too short, so I don't know what had happened, but I was able to just pop over to Home Depot and get the ones that fit pretty easily. I got them 8 millimeters. They were M3, and they were supposed to be 6 millimeters in here, but they were actually 5. So we were able to find the replacements very easily locally. Not a big deal. So as you can tell, I've got some waning light in here. So I'm gonna do a quick burn test that's straight up from the little card, the micro SD card that comes with the machine. They give you sample files so you can test very quickly. You don't even have to hook this to a computer, by the way. You can use a micro SD card and just pop it in right here with your designs, just like you would with like a 3D printer. For example, I have a resin printer, and that's normally what I have to do anyway with a USB device. So as you can see, I went ahead and I put down my aluminum plate. So this protects the table just in case I screw something up. There's also the honeycomb. I don't necessarily need the honeycomb. That's when I'm going to be cutting things. I'm not gonna cut right now because I would rather get some good lighting and daylight before I show you guys really what this machine can do. Okay, so the first thing that you're gonna need to do is focus the laser. As much as we would all like this process to be extremely automatic, it isn't. It's a little more manual. And even if I was using my CO2 laser, I would still be manually focusing in the software anyway. So, and you can see I went ahead and I put down this aluminum plate. This does not come with the machine. This comes with the honeycomb set from Longer. So I had to purchase this separately. A lot of people already have this kind of, this kind of protection devices around in their garages for people who are laser enthusiasts. I'm rather new to lasers, so I had to get it. So remember the thumb screws that were up at the front, you're just gonna gently loosen them and hold the laser head so it doesn't collapse. And then there's this weird cylindrical tube that they gave you that is made out of aluminum. You're gonna take that, and there's this little section behind the laser, and you're just gonna lift the laser, put this underneath, flat against the material, which, it actually would help if I had the material. See, I just like to keep recording my mistakes because, it's funny. So you're gonna put that down. This is what's gonna help you focus the laser. It's just, a little more manual than some things. And then you're gonna tighten the thumb screws in place. Of course, not too tight, but tight enough. You don't need to like wrench it to death. And then gently remove the focusing device. So this is the control panel that's up front. And I already put my SD card in. It goes into this slot here. It came on the thumb drive that is in the box with the machine parts. And by the way, this also has videos and photo reference and the instructions in PDF format. Highly recommend that you do that. I am a very visual person, and honestly, I had to go to the video to find out what was going on because reading instructions just does not work for me. So we're gonna go ahead and we're gonna engrave. So I'm gonna just click on engrave there. It looks like there's some files on here. Okay, a basswood engraving. So it's scrolling the text as it goes. So there's a bird. So we use the bird. And I already have everything placed where it needs to be. I'm concerned that I don't know. so we're gonna do a frame real quick because I don't know if it's centered or if it's user origin. What is it? So we're gonna do frame. Okay. So it did a thing. Okay. Oh no! Oh no! Oh no! No! I started it! I started it! Oh my God! Okay. Well, I started it. So there it is. Thankfully, I have my safety glasses on, so I don't need to worry about it. That's freaking fantastic. So it's now engraving. I didn't know the check mark meant start. So FYI, the check mark means start. I'm just gonna leave my mistakes in place so that people can basically see what's up. But I'm gonna let this engraving finish so that you can see those results.
Do da do ba do ba do da do ba do ba do ba do da ba do ba do do be do ba da ba ba da ba.
Okay, well, now it's done. I still find that somewhat fantastic that I screwed up that badly. But it's all good. Oh my gosh, that's so cute. Look at that. Straight up, straight out of the gate. All I did was accidentally hit a check mark. And thankfully I had this protective coat covering here. It didn't end up going over the edge, but we're good. Man, that looks really good. That's freaking fantastic. So as you can see, it's engraving pretty darn well. Okay, as you can tell by the lighting change, it's another day, which means I've had time to get acquainted with the machine, to do a few tests, and get plucky enough to make my bag tags. So what I'm gonna do is I'm going to do a material test, and this is a step that's very important. Not every laser is the same. Not every material is the same, and even material to material within the same type, it's not going to be the same. So it's important that you do tests for power and speed and for your interval, which is like your dots per inch. Every single time you want to use a new type of material. So I have these things dialed in with my CO2 laser. This is a diode laser. Things are going to be a little different. So I'm going to show you how I do my tests and use just the Longer Ray5. Okay, before we get started, we're going to do a safety check because now we have our material file ready to go, but we need to make sure everything is going to be good. So one thing to note, I'm in a garage. I have cracked the door so that all of the fumes are going to go over yonder. It's cracked primarily because of the backlighting. Normally I have this door wide open. I also want some privacy for my neighbors in case they're walking down the street or whatever. I'm also going to put on my handy dandy laser glasses because I want to look awesome and not be able to see absolutely anything while I'm trying to record this. However, the other thing is when I started talking in the previous clip, I realized that at some point we had slid this back and then had turned it on. So you need to move the x-axis and the laser head up to its origin point, otherwise it will yeet itself into oblivion. So let's not do that. So I'm going to go ahead and I'm going to place my material down right here, and since it's wide open as opposed to a lot of the desktop lasers that you see marketed these days, oh my goodness, we can pretty much just lay it in there, which is something I like. I feel a lot less restricted with this type of machine. So I'm going to move some things because I don't want to waste an ounce of this material. I want to make sure that I place it well. So I'm going to do some framing exercises to make sure I can kind of see where it's going to go and then place it in a lot better manner. All right, now that we have everything set up, let's go and frame it. Okay, I'm gonna just keep an eye on this. Whee! Okay, so basically dead center. Ta-da! Okay, now go home. Go home. Oh my gosh, it did not go home. All right, well that's probably for the best. So, oh that's right, I turned off that feature. It's all my fault. Okay, so I'm gonna move this around. I'll probably hit frame again because what I'm gonna do is you see how the lip of it is kind of held up a bit there. That's not good for this kind of material. So let's hit frame again. There we go. Okay, and that's fine. And I'm overly cautious about the placement of this stuff. You know, usually I'm pretty, I'm pretty good about it, but I definitely don't want to have any kind of issues. And don't mind me. All right, now what I'm gonna do is I'm gonna take painter's tape. You can use masking tape too. I mean, there's, equal opportunity tape. I just wouldn't use duct tape. You need something really gentle for this particular material, so because it can actually rip it up. And I'm going to just tape it down to ensure that those edges aren't poking up, because a minimal height difference with a material like this that is this delicate is going to have problems. So you want to kind of just tape it down to the aluminum here that's protecting my table from all kinds of bull hockey. And then I'm going to get our little doodad here, and I'm going to focus the laser. I'm just going to very gently, you don't need to take the screws out, just gently unscrew them and set it right on top of the material and just let it sit there in the back, and then tighten the screws. But again, not over tightening. And then once you remove it, you're focused, or at least for this material, and you have to do that for every material. All right, let's get it going. 23 minutes later, we have our little grid. You can see how absolutely little it is, because now you can see my finger for scale. I was actually really tempted to stop it in the very beginning, because the default for whatever it was is absolutely perfect. So it's kind of like, it's like, why continue except for demonstration purposes? And I will say, this is super quiet. This machine barely made a peep. You just hear the little whirring of the engine making it go back and forth, and that's basically it. So in looking at this, I actually think I'm just gonna go with whatever the setting is right here that was used as default. I believe that's actually gonna be, geez, it's kind of hard. I think it's going to be 322 for 22% power, 300 millimeters per second speed. Yeah. And this is also at the highest DPI that it can do as well, which is around 300 DPI. All right, let's not dilly-dally a second longer. Let's start working on those back tags. This time I'm going to move the light in so you can get a little better view of it. I think I need to work on the lighting in here.
Do da do ba do ba do da do ba do ba do ba do da ba do ba do do be do ba da ba ba da ba.
I just don't know what to say. They are so beautiful. These look so clean with the way that they've been engraved, that it's actually driving me a little nuts. So just as a comparison point, I'm gonna show you what one of these looks like after having been done on my CO2 laser. I always have chaos gremlin energy, so I'm gonna go right out of the gate and start with 1/4 inch plywood. Normally I would start with like 1/8 of an inch, because I use that for earrings, you know, the little dangly kind, and other assorted things like little miniature houses and such. But since a diode laser can't cut through clear acrylic, which is something that bag makers commonly use for templates, I figured I'd try the 1/4 inch plywood, because that's a really good alternative. As much as we would like to have like the clear presentation and to be able to fussy cut, this will work just fine too, especially if you're just going to trace. You're gonna get clean edges. You're not gonna have splinters or anything like that. And you can also basically sand this down and get a really nice finish with polyurethane. So if you don't have the budget for a giant CO2 laser, let's think about the diode when it comes to making the bag templates. All right, without further ado, let's go into it. Okay, I didn't quite cut through all the way, so I'm gonna give it another go. This is me for the first time trying to dial in those settings, so this makes total sense. I'm also going to go ahead and go around each of the letters with a little score line. That helps to make the engraving stand out quite a bit more from materials such as wood.
Do da do ba do ba do da do ba do ba do ba do da ba do ba do do be do ba da ba ba da ba.
this didn't actually cut all the way through, and I went at 100% power, but I was a little fast when I did the cut. So what I'm going to do is I'm going to slow it down, leave it at the same power levels, and see if that's going to help. This also might be one of those materials that's going to need several passes. As far as the soot that you see around here, I actually do not have the air assist unit hooked up yet. So once I have the air assist unit hooked up, a lot of that is going to die down. Air assist isn't required, but it does help prolong the life of the laser head, the lenses, and the mirrors. So that's something I definitely want to be able to install at some point. I just didn't do it for the video because they're super loud when you hook them up. All right, so I'm cutting the speed down to half, or from half, rather, math, yeah. So did you see the poof of flame? So the poof of flame is totally a normal thing if a piece falls off. Okay, now you see how I'm just like kind of poking at it and it's wiggling? That means it's cut through. So I'm going to go ahead and just lift that up. Because the thing is, if you didn't, then it's out of alignment. And you will never know how it did. Also, because I'm a merciful God, I'm going to show you a couple of different ways that you can actually clean off the soot. If you're going to be doing something like staining this, you don't really need to worry about it. You can just stain it and it'll go away. You can sand it lightly if you want, or you can use a cleaner, something that's not terribly abrasive, such as LA Awesome. The stuff is totally awesome, apparently. And do that, just clean it with a towel. Don't use paper towels because they'll shred inside here. Also, don't use baby wipes. I mean, seriously, ask me how I know. So I usually sand it anyway, just a little bit, because when you go to stain it and seal it with, you know, a high gloss, it won't show anyway. Like the gloss just won't work unless it's nice and smooth. So that got rid of a lot of it, except for like around here. This is a hickory though. So I'm just gonna very lightly spritz it with the cleaner and then wipe it off with the towel. And you'll let that dry, but basically it just comes right off. The other thing you can use is just water. You know, you don't have to do anything super fancy. You can use water with this, but bear in mind that you know, every material, like I said earlier in the video, every material is different. All right, so clearly it's nighttime. You can see right here. So let's go back up to the sewing room and I'll give you my final thoughts. Welcome back to the room. It's really bright in here. It's kind of magical how I can just change the time of day and my clothes on a whim. All right, so I've had a handful of days with the Longer Ray5 and I'm pretty impressed. One of the things to note, based on my experience with the CO2 laser, is that the diode's going to be a lot better at doing like fine detail engraving. That's why I've noticed a huge difference between like the bag tags that I've done with the CO2 and then now seeing them with the diode laser and going, oh my gosh, it's so sharp. Ah, it's so different. And that's just because of the differences and the size of the laser beams between the two types. So there's 3 core types of lasers. There's the diode, then there's CO2, and then there's fiber lasers. All of them do things differently. They all handle materials differently. Some are better than others. And a lot of people who really get deep into the laser engraving and cutting rabbit hole will have one of each at least. So it's not bad to assess that. The big thing, because we're bag makers here, or sewists at the least, right? So why would you want something like this? Really, I'm making my own bag tags. I know I have the metal ones, but now I'm going to make some really snarky, funny ones that I can put on the inside of the bag that if somebody sees, well, it's funny. And I can make my own templates. And while I can do that with acrylic if I need it, I can also do it with wood. So if we take the little test template that I cut out and have the camera try to focus. So this is just the one I did with the wood. I haven't even treated this wood. All I did was clean it to get like the soot off of it. And it's fine. I'm not going to get splinters here and around the corners and crap. It's a 1/4 inch of plywood. It's fine. Again, if I was fussy cutting, that might be a little different. But there's nothing wrong with taking something like this and using it as a template. You know, it's basically, and it's not all acrylic that it can't do. It's certain wavelengths. So a diode laser is a blue laser. So based on those wavelengths, it's not going to cut through clear or opaque plastics. But if you put just plain old like red or blue or orange, yellow even maybe, and black, clearly just straight up opaque acrylics, then it can do it. It's the clear acrylic that it has a problem with. But in that case, you might as well just do the wood. And you can use markings. You can absolutely just use markings. I very rarely fussy cut. It's like not a thing. Typically, if I'm doing something at like a production level, I'm just going to cut wherever I'm cutting. The most I'll pay attention to is like where my tag is going to go. Because as nice as it is to label your products and say, yes, that's mine, it's your artist's signature, that's another discussion for another day, possibly a seam ripping. But, you know, you don't want to obstruct the main bag, right? You don't want to cover up somebody's face, for example. That would be terrible. Who would do that? Anyway, so these came out so well. And I think the thing that impressed me the most, let me grab it, was the, oh God, the blood, so much blood, because that is a super fine detailed font that is really hard to do with the CO2 laser. With my CO2 laser, that turns into a blob. It really does. And I can do it and I can tune it, but usually what I have to do is expand the scope of the size, like give it like a fake bold effect using Illustrator, to just, you know, outline the strokes and then do an offset. And it's, you know, it's a hassle, and I don't want the font to look like that. I didn't want it to look that way. So I will primarily be using the diode laser going forward for the finer detail things such as this. It works really well with this leatherette. This is not real leather. Shocker, I know. I actually am too chicken to work with real leather. It's a story for another day. So I'm really impressed. I loved it. It was really easy to set up. You know, I will admit that I used the video more than the instructions. There's paper instructions that come with it, but also on that micro SD card that they give you with the USB dongle, there's also instructional videos that take you step by step on what you're supposed to do. And you can kind of watch them and pause and go do what you need to do and kind of do it at your own pace. That was a lot easier to me because I'm a visual learner and I'm not terribly mechanical. I know it can come off like I know a lot of things sometimes with all the different hobbies that I do, and I'm a programmer by day, but I'm not mechanical, and I don't have the tool set or the skill set to put things together like that. I still ask my husband to do my IKEA furniture, but this wasn't that hard. And it, like I said, like I did the material test and I had everything dialed in right away. That was easy. That was nothing. I feel like even if I didn't have laser experience, this would have been easy to set up and get working with. So yay. Anywho, let me know what you think down below. What are the kinds of things you would make with something like this? Like, what would you do? I'm all about like wood keychains. Like if you can do 1/4-inch plywood, you got keychains in bag. Keychains, bag, little bag charms that you can make. Oh my gosh, so many things. There's just bookmarks. Ugh. Anyway, I just feel like since discovering lasers, my creativity has been unlocked and I am just coming up with all kinds of wild ideas. Until next time, my friends, stay thirsty